Good, all right. Here, I think we need you to have a mic. All right, all right. You want to just check if that's working? Just keep trying. It's gonna.
Hello, hello.
There we go.
Okay.
Okay.
Good.
Hey, everybody. How are you? How are you feeling? So this is our outro presentation for ZK Hack Lisbon. We will be finding out who won, honorable mentions, etc. I hope you're all feeling really good. I hope you enjoyed the lunch in the sun. I hope you enjoyed hanging out. Okay, so I think you all know this by now. This is where we live. This is the Discord. If there's anyone who just arrived, join our Discord. It's very active. If you're not familiar with what ZK Hack is, we're here at ZK Hack Lisbon. ZK Hack is actually a larger project. It's a learning hub for ZK stuff. If you're interested, always check out zkhack.dev and head over to our Discord. And this is our Twitter, if you feel like tagging us or something. Okay, so ZK Hack Lisbon, it's a wrap. I guess for this presentation, we're gonna be sharing first the bounties from our partners, and then we're gonna be doing general prizes, so we're gonna announce the winners, and then we're gonna ask our top 3 prize winners to come up and present, so you actually get to see their projects on stage. So to start, though, I wanna say a big thank you to the partners who made this happen. These are our partner teams who you might have seen. They've done workshops. These are also the teams that offered bounties. So for our partners for ZK Hack Lisbon, we had Aleph Zero, Polygon, Risk Zero, the Polkadot Treasury, and Moonbeam, as well as Sysmo. So thank you to our partners. Let's give them a round. We also had our based sponsors, Scroll and Jump. Scroll also offered bounties. I know some of you went for it. And on the community front, we had ZKV, Aztec, 1KX, WorldCoin, and Snarkify. So thank you to all of our sponsors. So next up, we're going to be announcing the bounties.
Yep. So next up, I would like to invite someone from Risk0 to present their bounties.
Okay, thank you.
All right, thank you. First of all, thank you to everybody who participated. We had a huge number of people work with Risk0 and would always appreciate feedback, so anybody who worked with us. Can the folks who are working with Risk0 stand up real quick? I'm sorry, I'm gonna put y'all on the spot. Oh, I'm sorry, the people who are employed by Risk0, can y'all stand up? There we go, okay. Should have been more clear on that. So if you can't come back to our booth after the event, feel free to find one of those folks and just have a conversation about anything you ran into. So for the awards in the crate category, we have Pavlov's Dog for their HMAC implementation for the Risk0 ZKVM for 1,000. Zero Skill with, and then my personal favorite, Zero Skill with Mindfuck code obfuscation for fun and profit for $2,000. So, yeah, I'm sure we'll be announcing our new language support on the website shortly. In the ZKVM app category, we have Alexander Kozlov with Whitebox for his idea of wrapping the ZKVM in an endpoint for $500. And Zero Dem with Ting Tong, a turn-based guessing game, also $500. And we've got WaveAct with cross-chain escrow on L3 to L1 validity rollups for $1,000. So, and then, so 3 more to go, bear with us. We've got Top Secrets with Dread Pirate Roberts Marketplace, a ZK reputation-based marketplace for high-value transactions for $1,000. And then we're really excited to see hardware involved, so NVID with the proof of physical item using NFC devices with on-device AES keys, you've got $2,000. And then Also exciting, we had ZK Techs with a zero-knowledge decision tree prediction program for $2,000. All right. So just once again, if you worked on a project after the awards ceremony, if you can come by our booth, we'd love to have a conversation with you and give you dollars.
Thank you so much. I'm just going to grab one more mic. I want to make sure that's on. So this is for the guest. All right.
So next up, we have Sismo.
Hello. So yeah, thank you all for building on Sismo. It was very, very interesting. We have a lot of feedback, so we are going to improve all of what we did. And yes, so now the bounties. The best on-chain ZK Connect application, which was 1,500 USDC, is for the ZK Safe project. So the ZK Safe project enabled to use a safe smart contract wallet from a Web2 account, like a GitHub or Twitter account, and without the need of private keys using the Sismo Data Vault feature and the ZK Connect. The second one is the best of, sorry, yeah, we can.
Yeah.
The second one is the best off-chain ZK Connect application with 1,500 USDC. So it's a sysmord that's enabled to get access to Discord channel in a privacy-preserving way using ZK Connect and with verifying the proof of chain. And the third one is 1,000 USDC with best data groups. It's a Zclone that created something like a tornado cache using Sismo. So. Thank you, and congrats.
Thank you. So many prizes. This is amazing. All right.
So next up, we would like to invite Polygon to announce their prizes.
And I guess this is both Polygon Maiden and Polygon ZK EVM.
Yes. Yep. This is for you. Thanks. Hi. So for Polygon Maiden, we had very cool submissions, and the winner for add a cool thing to the Maiden standard library was Goblin Oats and Wei G for creating the Al-Gamal encryption for the Maiden standard library, which is really nice. And they actually wanted to build ZK Mafia, which we hope we will see next time. And for our second bounty for Polygon Maiden, build an awesome application, we got an AMM, an automated market maker for Polygon Maiden from Sergey. Oh, there you are. Very nice. And for the ZK EVM, unfortunately, there were no submission. But I should remind you that there are bug bounties out there up to $1 million if you find a critical bug in the ZK EVM. So if you have time and linger around, cool.
Find the bug.
Actually hack the thing.
Yeah. All right.
So next up, Alif0.
So we decided to award one bounty for Dread Pirate Robbers Marketplace for a very nice trust network, kind of, and using a marketplace as a vessel. And as we promised 10K as a bounty reward, we decided to give the other 5K to the general hackathon bounty. So the general hackathon winners will just get additional dollars. Thank you.
Cool. Thank you. And scroll.
Thank you. We are Scroll. We were that ZK rollup. That's not a ZK rollup. but I'm very happy to announce this changes today. Just a few minutes to the deadline, we received a very cool project, an L3 on Scroll, making Scroll the first ZK EVM as of today.
Nice.
And so our $1,000 award goes to Matt from the ZK EVM, who actually did manage to deploy contracts from the now sunset Aztec Connect to Scroll's alpha testnet, L2. And so that means that you can now use all of the might and magic of Aztec ZK rollup and have it settle as a base layer onto Scroll's ZK rollup.
Wow. Inception.
The other thing, though, and the reason why we are a ZK rollup and not a ZK rollup, we Scroll, is that we have this very boring DevX. And so our $2,000 award goes to the team behind Fruity Friends, who actually managed to mistakenly keep the environment variable for the local debugging environment set to Scroll's L2 RPC endpoint and not notice it, deploy the contracts as tests a couple of times to the actual remote testnet, and they only noticed once they actually wanted to deploy the real thing. And they actually did not even need to move from a local node to Scroll's remote node. And so our 2000 Grand Prix goes to the at least French-speaking team, so that fits well as well behind Fruity Friends, who are actually able to make ZK preference matches between any of your secret private preferences for fruits only manifest if another person has the very same preference. Congrats.
Nice. And I guess that leads us, so that wraps up our bounties. Thank you to all of the partner teams, based teams for offering these bounties to everybody. Let's give them all a hand.
All right, so let's start with third place.
We have our winners. So wait, before you do that, let's give some context. This is the ZK Hack Lisbon winners. So you all met with judges. We had 4 groups. We had 33 teams, I think, go through the judging. It was very challenging at times. There was a lot of close calls, but we figured it out. So yeah, we're gonna tell you who won now.
All right, so for third place, ZK Save.
Woo! But actually, yeah, so just stay there for a bit. We're going to announce all the winners. Oh, why don't you stand up and wave? But after this, so we're going to go all through the winners, and then we're going to have them present. So you'll come up after that.
Yep.
All right.
For second place, ZK Peer-to-Peer.
Woo! Where are you? Do you want to stand up and wave if you're in the room? Nice.
Awesome. Want to take the first prize?
First place. So this was a team. I mean, I unfortunately was not on the judging team, so I'm very excited to see the presentation. But we heard rave reviews from the judges who saw it, and it is. I'm trying to leave a little suspense here. Zero gravity. Very cool. Why don't you stand up? This is our team. And so you're the first place winner at the first ZK Hack IRL, ZK Hack Lisbon. So congratulations. You saw we did a hacker's choice. You all voted. I think you can kind of see the winner potentially, but I want to say hacker's choice, Fruity Friends. Where are you? Oh yeah. You want to stand up and say hi? Okay. You do.
Awesome. So for honorable mentions, so these are projects that did not make it in the top 3, but we think that they're great and they've done lots of good work. So to start, we have Zero Trace, Starkside, and ZKDDP. Zyklun, Sysmord, ZK Wordle.
So why don't we give a hand to, these are the honorable mentions. And then we have honorable mentions chewing glass, as Zach called it. These are very difficult tooling projects that it's incredible that they were done in a weekend in a hackathon. So we want to say a big shout out to El Gamal and Poseidon too. Is it chewing glass or is it eating glass? Help me. Chewing, was it right? Yeah. Okay, very good. I don't know what's after this. What comes next? I don't know what the slide is, so I can't tell if I'm supposed to.
I think you can press next.
Oh yeah, okay, it's the end. I literally don't have a prompt here. Okay, so we are now going to be hearing from all of the top 3 winners, and I think we'll start with the third place. So if you want to come up, we're going to do a little changeover. ZK safe. Yeah, you can just put it down, I think.
Yeah.
You're going to need this, right? Actually, I just put one of the mic. Oh, you have 2, right? Yeah.
So this one,
Just put that one in. We should get off the stage, I think. Everyone's daft off.
Okay, cool. Okay, so thank you. It was very nice. The first hands-on for me about ZK Tech, and today I wanted to present you this idea about ZK Safe. So you can use your Gnosis Safe using your Web2 credentials, or anything that you can attest using Sysmo ZK Connect single sign-on. So the idea is that currently accounts can be controlled only by private keys, and Gnosis is a way for controlling accounts using smart wallets, but still you have to use private keys. So what if you can operate your vault, operate your safe using your Web2 accounts, or maybe delegate a third party to social recover your account in case of issues? So that was the idea. So mix the Gnosis Safe technology with Sysmo to create the ZK Safe. So let's see how it works. So Gnosis Safe has this framework named Gnosis Safe modules that can enable you to extend the functionalities of your safe, enabling third-party contracts for extending how you can interact with your safe. So you can set up spender limits, recurring transaction account automation, or delegate to a DAO to perform specific action with your safe. Sysmo instead launched very recently ZK Connect, that is a way to make a single sign-on in a privacy-preserving way and attest that you own specific Web2 accounts or that you have valid claims off-chain. So the idea is that you create a Sysmo group where you make all those rules off-chain. You deploy your the safe module that I built in the hackathon, and you enable your module inside your safe. So delegating the control of your safe not only to the account owners but also to the safe. In this way, you can control and so operate in your vault with the attestation that you can do off-chain, extending all the capabilities. So how would it work practically? So you have this nice front end where you specify the safe address where you added your module, the operation that you want to do, a payment, or let's say recovering the account of, recovering the owner of your safe, and then the off-chain part. So you choose what you want to do. You make a ZK Connect request. You go in the Sysmo Vault app where you unlock your vault. You generate your proof, and then with that proof, you go to the module. You submit the proof with the transaction that you want to do, and it's it's done. Briefly, just to show that it works, here the front end, here is the safe that I configured. This is the payment that I want to do. I click to ZK Connect, I go here, I have unlocked my vault, and I can attest that I belong to the group that I delegated to operate in my safe. I send the message, creating the ZK proof, and in a few seconds, you will get back to the original front end, and you can execute, hopefully not, but believe me that you can do that, and this will be the result.
Yeah.
So, I mean, I'm very excited about that just to, because you can extend the programmability of your account to anything that you want to do and you cannot do on-chain with the power of ZK Connect Sysmo. So you can implement recovery schemes, custom access control list, delegation, and any rule that you want to do, and you don't have to disclose nothing on-chain, and with the power and the capabilities that you may have off-chain. And that's all. Thank you very much.
Thank you. Thanks so much. Okay, next up, we have our second place winner, ZK P2P. Where are you guys? Yes. So we have a bunch of, I think you have multiple folks who are going to be up here, so we can give you all the mics.
All right. Can you hear me? Yeah, cool. We are ZK P2P. So as we are all probably pretty keenly aware, there's huge barriers to on and off ramping your crypto. So oftentimes you have to go through a centralized entity, or there's some sort of delay, especially if you're on ramping. You have is it
into the microphone? Yeah.
I don't know what you guys heard then, but so yeah, there's obviously big issues with on-ramping. You either have to go through centralized entities, or there's some sort of delay to actually get your funds on-chain. And so we came up with a solution to get your funds on or off-chain in a decentralized manner with pretty fast, it doesn't take very long. Here we have a little demo of this as well. So basically what happens is first you submit an order on chain. Once you submit, you specify an amount of USDC you'd like to receive on chain and an amount of US dollars you're willing to pay off chain. And I should mention this is all built on Venmo. So, but it could be extended to any sort of like P2P payment network that sends you confirmation emails, essentially. So yeah, you can create the order. We have a bunch of orders over here that are pre-filled. They're actually orders, but pre-fill them. And then anybody can come through and submit a claim on an order. So when you claim an order, it doesn't mean you're automatically getting it. You're basically bidding for the right to kind of make this exchange, right? So in theory, as a claimer, you should collect some sort of spread for helping someone onboard. Whether that's, you kind of, when you claim, you also have to lock up your funds on chain and create an escrow, right? So you want to be compensated for that, as well as the, a convenience fee. So when you submit your claim on chain, you also get the person who's trying to on-ramp, their Venmo ID, that you are then able to send a a request to that Venmo user requesting a certain amount of money. So now on the on-ramper side, you are getting a bunch of requests from people who are these kind of like either it could be like a market maker type or it could just be someone trying to off-ramp. You can choose the one that you want to use, and you complete the request from their email. So then once you complete the request, you're now getting a confirmation email sent to your address. So then you can take that confirmation email and you can submit it into our UI. And this will parse that confirmation email, pulling out the order ID and the kind of on-ramp and off-ramp Venmo IDs, the user IDs for those two people. And then you generate the proof. We're doing it remotely because it's
way too slow.
It would be slow otherwise.
It's going to take 60 seconds, so keep talking.
It's going to take 60 seconds. So yeah, it generates the proof, and then once the proof is generated, you can submit the proof on chain, and in submitting the proof, you unlock those funds that are escrowed for you by the person that claimed your order. And now you've onboarded.
Keep vamping.
Yeah, so obviously this has, we think this is pretty exciting. We're interested to see where we can build this. I think there's a lot of improvements we can make from like a privacy perspective. But also this, like I said, this can be extended to any sort of P2P network or even potentially banks, right? If they were to sign some sort of confirmation email for you. Also would like to shout out the ZK email team, which is also, I believe, Persona Labs now. We use their circuits to be able to derive, or we kind of modified their circuits to be able to be compatible with these Venmo emails. How are we doing, Richard?
Okay, yeah, proof generated.
Good. All right, proof is generated. Now we can submit the proof. And we should be able to see, once this mines, you should see a certain amount of USDC, fake USDC, I should say. Oh, is it still mining? Cool. Any minute now.
Dealing with blockchain.
Well, yeah.
Yeah.
I don't have anything more to say. We waited this long, right?
Yeah, I would just add that if you generally subscribe to any of the trust parameters around, I think this was first proved, as Brian mentioned, by the folks behind ZK Verify Email, and the proof in the pudding is the digital signature that comes as a part of the original email that you can download, and that's what we're submitting in order to generate the proof. And so this can extend to really any service that provides a digital signature as part of any type of flow. Again, if you're willing to trust those assumptions.
There you go. The USDC was transferred.
Fantastic. Live demos on chain, on stage. That is, well, on a chain. All right. So now we're going to have our first grand prize winning team, a big team. We only have 4 mics. Do you? You could just one? Okay. 0 Galaxy.
Gravity.
Gravity. I'm tired. Sorry. Gravity.
Does anybody want to join? Test. Cool. So I wasn't told there was going to be a demo required, but I'll just start the prover, and then maybe by the time we're done, it will have finished. So starting off, yeah, we did a ZKML project proving inference of zero knowledge of a machine learning model. And oh my God, this was a wonderful weekend, and this would not have been possible with every single person sharing a little bit of knowledge about cryptography, machine learning, and trying to make this all possible. And it started from an idea to, I really like lookup tables and all the recent advancements that have occurred in the last couple of years. And we've seen that they are used a lot to basically make proofs of computations, which are normally not very amenable to ZK proofs or to circuits. So yeah, with help and input from a lot of other people, we were pointed to some papers that actually take the idea of lookup tables to a full extent and really make optimal use and find a network which is perfectly able to be proven in zero-knowledge proofs instead of trying to work our way around a difficult architecture.
Yeah, so we think there's some really compelling use cases for ZKML. So for instance, biometric identification, that sort of thing, where you want to prove your identity, but you don't want to send your biometric information to an untrusted party. So you might use a public network, for instance, that classifies biometric data as coming from Victor or Ben or George or Hamish and so on. And what you want to do is get a proof that when you put that private input in and you run the prescribed network, then what comes out is indeed Victor. So the fundamental challenge we found with ZKML is that you're trying to reconcile two fundamentally different sets of primitives. On the one hand, in the neural networks with which we're all familiar, everything's done using floating point arithmetic, matrix multiplications, and nonlinearities. And on the other hand, in the ZK world, what it's all fundamentally about is finite fields and modular arithmetic. Obviously, we build a lot of stuff on top of that, but fundamentally, you're in a discrete world, which is very different from the world of neural networks, floating point arithmetic, backpropagation, differentiable functions. So people have tried to bridge that gap, and with some really innovative approaches, but they've all involved basically truncating the weights of your network, quantizing or discretizing these weights, so that you can fit these familiar neural networks into a ZK framework. This is a really cool idea, but it has its own challenges, and it necessarily damages the accuracy of the neural network that you're trying to force into ZK. So we sort of felt that this is kind of like square peg, round hole. Like, it just doesn't feel quite right. So we thought we'd go back in time, as Victor said, and find ourselves a new, well, or rather a different machine learning paradigm that doesn't use floating point arithmetic. So we went back and we found these things called weightless neural networks. So this is before backprop, before neural networks as we know them today, and they're entirely combinatorial beasts. So they learn patterns not by using differentiable functions and backprop, but rather by just identifying patterns in the inputs, which are bit strings. So it's basically a big lookup table, and these are made scalable using Bloom filters. So what's exciting about it is being combinatorial, it's much more amenable to being implemented in a proof system. So we're able to take a pre-trained weightless neural network and come up with a proof system that will prove an inference run for such a network without any loss in accuracy of the network. Yep. So it's really quite cool. So I guess we haven't got a demo, but the contributions, I guess, are like we've got a nice open source repo, which we really hope other people will look at and build upon. And hopefully also it'll stimulate some other ideas about how we might do ZKML in a less square peg round hole kind of a fashion.
indeed. So yeah, to summarize, we can do bigger proofs, bigger neural networks, hopefully, and maybe one day OpenAI is going to run weightless neural networks, so they can actually prove and attest to you that what they're running is correct. Here's a GitHub repo. Feel free to play with it, and happy to chat more. Thanks. Oh, and it's the green. It worked.
Incredible. Oh, I still have my laptop. Now I wish we had actually had, I mean, this is amazing to see you present this. We only got to see as judges only a quarter each. And yeah, I feel like we've learned a lot on this ZK Hack Lisbon event about hackathons and how we potentially want to do them next time. I mean, yeah, it's so amazing to see your presentation up here, all three of your presentations, and now I wish I could see everybody's presentation, but I guess we'll have to look at the dev folio for now. Okay, we have now reached almost the end of the outro of ZK Hack Lisbon. Obviously, we have to, I mean, this is the team that made this happen. I mean, there's a few people who aren't here. Kobe and Antec weren't able to make it here. But the folks that are here, Natalia, Agnieszka, Thor, Hector, and DC Builder, thank you to everyone who contributed. I want to say big thank you to the judges. If there are any judges, do you want to just kind of put your hands up so we can cheers you? Thank you so much. Thank you to this team who really made it happen. Let's give them a full hand. This was a lot of work, and it worked out, and I'm so happy with how it turned out. I hope you guys liked it as well. I mean, we want to hear, as we said sort of at the beginning, this was our first time doing it. We have learned a ton on actually how to even like understand what ZK projects could be kind of categorized as, you know, what people were able to build in a weekend. This was all learning for us. And we do want to do another one, probably in the fall, probably in a different city. So keep your eyes out. We will be back with another in-person ZK Hack, I think, I hope. And yeah, I don't know what else to say. I guess I do want to say like a massive thank you to the venue, to the folks who like, I mean, I don't know if we're in this awesome library with all of the books, and it's just great to be here for this wonderful weekend with all of you. So thanks. Cool. So that wraps it up. I know that tomorrow there's a bunch of events happening. I don't know if you're all aware. There's some free events.
There's the ZKML meetup tomorrow.
Oh, yeah. There's, and then on Tuesday, I know some of you might be coming to the ZK Summit, and yeah, hope to see you all for a few more days, maybe. Okay.
See you around.
Bye.